Welcome again. Today I would like to explain technical term scotch yoke versus rack and pinion for pneumatic spark-turn actuators. About this problem was mentioned so many difficulties and so many discussions regarding the pneumatic spark-turn actuators. I would like to take the opportunity to report on the best choice between the different technical solutions offered by pneumatic spark-turn actuators. Basically, what we mean by the term scotch yoke. Actuator delivers the transmission from a linear movement into the rotary action, known as a spark-turn action, by means of the lever arrangement. No gear shaft, no gear rack on the piston. This makes the machining independent from any material to be used for the shaft. Just think for a while of the difference in the machining: stainless steel teeth or maybe aluminum teeth on a shaft. Difficult. If you look at a hobbing and a pressure balance shaft, so-called floating shaft, which makes the shaft blow out safety and reduce the wear and tear tremendously. The result is a wider material selection for the shaft, as only turning and drilling is necessary, and a perfect solution with a low wear and tear. All the used material can be selected according to the operational condition and can be hardened. Just think on a cam disc in combination with a bearing, pin and a piston. Frequently those actuators will reach a life cycle time of 1.5 million cycles. By my experiences shows in application with a combination with the ceramic valves assembled. If we talk about wear and tear, we should not underestimate the abrasion within the gear transmission. The aluminum particles together with the oil or grease inside the actuator form a grinding paste, which result is an even faster damage of the actuator. And in the worst case scenario, as well, the abrasives infiltrate the compressed air system and damage upstream or downstream components, for example, solenoid valves, valve terminals. Once again, we have to consider that when using pressure-dependent sealing rings or slide rings with graphite, maybe Teflon compound material and lubrication of the air is no longer necessary, so that the effect of having abrasives inside the actuator is less destructive, as well as a reduction in the maintenance. That means refiling or draining of oil. The lever arrangement is responsible for the different output torque compared to the rack and pinion actuator. It means for a linear constant torque curve. It's important to note that the scotch yoke actuator delivers a 20% higher breakaway torque from the zero position, where any soft-seated valve requires the highest available torque, for example butterfly valves. Whereas along the rotary movement, the available torque goes down to a value 45% lower after the 50% travel and increases at the end slightly to 75, maybe 80% of the starting torque, which benefits the torque requirements of soft-seated ball valves. The benefit for the user is either a smaller actuator or a higher breakaway torque, considering the same diameter of the piston in the actuator, resulting in a cost benefits and a space saving. Two different systems. Why we have a two different system? Most of the suppliers will define a two different actuator system in a way that use the rack and pinion actuator for a control purposes. That means if you need to control flow in a valve, because of its linearity, and the scotch yoke actuator for an on and off application, mean using for the shut-off valves. Application as the scotch yoke actuator is able to hold intermediate position. If you look as a common torque curve of a butterfly or ball valve, for example, we will see that these valves have a reduced torque demand during the travel, resulting from the balance tendency to open or close initiated by the media stream under circumstances that 75% to 80 of the torque requirements in a soft-seated valve is generated by the seat. Thus, we have a little problem here, but please do not forget about the previously mentioned design criteria. No O-rings, sealing as a dynamic sealing. The best option is a pressure-dependent lip sealing, as it delivers the least possible leakage. Second best is a combination of an O-rings with a graphite or PTA5 slide ring, which reduces the friction in a slipstick effect. This gives the best possible result from smooth operation and precise use of valve controllers. There are also, of course, limitations on the scotch yoke systems. It is necessary to operate 3-way or 4-way valves, which require a turning angle of 180 degrees. It is not possible to use a scotch yoke actuator, as the lever arrangement does not allow turning more than 95%. However, considering all the benefits of the scotch yoke actuator is the best choice in automatic valves with a 90% turning angle, such as butterfly ball and plug valves for on and off operation, that mean shut-off valves, as well as a for control application. Thanks for watching. Please subscribe.